coming over to my channel. So just to start off, this is going to be a re-recording of my first video. I accidentally made a boo-boo and want to fix it because it's a little bit of an error on my part. So what I said was the observer height calculator formula, or distance to the horizon formula, is 1.22 times the observer height. That is not exactly correct. It's actually 1.17 times the observer height raised to the 1/2 power. If you're going to argue with me on the 1/2 power, then you don't understand what I'm talking about and need to start looking that up. Simple math. Don't make it complicated. So, a flat earther will say that the formula is no more than 1.17 times the observer height raised to the 1/2 power. That's not true. It's less than. It's not more than. And it's a simple observation that even I can make. Go lay down on the ground. Look at the horizon. I obviously can't go less than anymore, right? Right. So if you hear somebody say more than instead of less than, they're either lying to you or don't know what they're saying. Either way, they're wrong. Because I can go up and on the top of my house, I can go up into a plane. That's more than. Less than is me laying down on the ground. I can't see less than my observer height down. So when we do the calculations, it's no less than 1.17 times the observer height raised to the 1/2 power. The next thing is going to be on boat phenomenon going over the horizon. The idea is, well, if you look at a boat going over the horizon, it disappears from the bottom up. That's a crazy phenomenon. I ask myself, is there a time that I observed that same observation? And yes there is. Just go watch somebody walk down some stairs. They will disappear from the bottom up. Simple as that. The next one is going to be on dimensions. The flat Earth is a two-dimensional system. It's not a three-dimensional. And we happen to live in a three-dimensional universe. Length, width, and height. We don't need to worry about time on either notions of flat Earth or globe model, if you want to call it that. We happen to live in this type of universe where there's length, width, and height. Simple. When you go and look at other things in the universe, even here on Earth, large objects, I mean really large objects, obviously can't exist as a flat Earth or a flat plane. It will collapse in on itself because the way mass and gravitational attraction works. Okay? Space-time, scary stuff for some people, which I'm sorry that you think this is complicated and hard and scary. And guess what? Math isn't hard. The fact that you don't understand it means you haven't done enough research in real mathematics on how to calculate out, we'll say, heck, a derivative. A simple x squared derivative. If you know what the derivative of x squared is, please comment below. So going back to the conversation, we live in a three-dimensional universe. So, you look at the sun, you look at the moon, you look at everything. They collapse into a ball. Very simple. We can't have a flat Earth in this universe. It's impossible. The only areas that you can are where there's a lot of space between the objects, like the solar system, the galaxy. Okay? Those ones can be disks just because the distance between them is so vast that space and time will allow these three-dimensional globes to have a plane in them. Nothing more than that. Sorry, it's physically impossible to have large objects being flat. The next one is an eclipse. Solar eclipses, to be more specific. We know that the solar eclipse, the sun, the moon, they all go from east to west, right? Well, when a solar eclipse happens, same thing. We have an east to west direction. And makes you wonder, well, are there locations on said planet that we can observe the solar eclipse going from west to east? And can we do that on a flat Earth? Well, let's ask the flat Earth ones. Is there any areas that we can have a west to east solar eclipse? The answer is no. There's absolutely no location that you can have a west to east solar eclipse. Whereas on the globe, you can have both east to west and west to east observations at the same time. Comment below on where you believe this location is at. Finally, let's talk about bendy water and how supposedly water doesn't bend. It's kind of interesting since it's a fluid. It flows. And yes, you can have bendy water. Just go look at waves. Go look at droplets of water. Heck, guess what? You can even go look at a large body of water and it bends too to conform to the earth. Very simple. It's not complicated. If your incredulity is getting in the way, you need to probably figure something out. We don't live on a flat earth. I'm sorry, but guess what? This is reality, and I don't like fake bullshit. Finally, let's see. I think that's about it. I might be doing another one on gases and how the different layers and masses of gases from the top of the atmosphere down here, and how we technically do create a container for us, even though it's not a container, because people will argue that it's not a container, even though it is, and how it actually works. I might do that. Comment below if you want me to give a little bit of explanations on how that works. Alright guys, like, share, comment below. Have a wonderful day. Viewfinder, stop recording video.